In this video, I'm going to show you the multiplication properties of exponents and then some examples to go along with it. So hopefully by the end of this series of videos, you'll understand what the multiplication properties are and then why exponents are added when powers of like bases are multiplied or subtracted or even multiplied. So we'll talk about that. Multiplication properties of exponents, there are three. And the first one is called the product, meaning there's a multiplication of terms that have powers. And if you notice here, I'm going to expand this. X squared is the same as x times x. And then I have my middle multiply dot. And then x cubed is x times x times x. So the total number of x's that we have being multiplied together is 5. And what we're going to do is add our powers here, because 2 plus 3 is how you get 5. Now look at the difference here with the next one. It says a power to a power, power of a power property. Now I'm going to expand this to show you what we do. If I have x squared, that's x times x, and I want to multiply that base 4 times. So I want an x times an x, times a second x times x, and then a third x times x, and then another x times x. So notice how that base was multiplied 4 times. The total of number of x's that I have now is 8. And what we do with our powers here is we multiply those powers. So more quickly, without having to expand, 2 times 4 is how I got my 8. And then the last rule is when you have a power that's being multiplied to a product. So notice how this product is going on in here, x times y, and that product is being multiplied 3 times. Or more simply, xy times xy times xy. Now if I multiply my terms that are alike and put them together, I would rearrange like this. X times x times x and y times y times y. So x cubed and y cubed. And really what you do here is you distribute your power. So for my rule for any number of powers, here I said add, here I said multiply, here I said distribute. Notice how I'm going to write out the rule here. So if you see a product of powers, you're going to take your base and your exponents you're going to add together. So if you have the same base, meaning the same letter, then you can add your powers. And again, if you have a base that's already raised to a power, so power of a power, raised to an additional power, we would take our m times n, because we did our 2 times 4 and we got our 8 here. So to find a power of a power, you multiply your exponents. And then the last rule here, when you have a power of a product, you find the power of each term. So here, you find the power of each, a to the m, and then b to the m, and then if you need to do more simplifying after that, you'll do it. So I'm going to give you in this first video multiple examples of our first rule, which was product of powers. So again, I'm going to do product of powers here, and then I'm going to show you 5 examples. So if I have the base of 4 repeated, the same base, all I need to do is add my powers. So here I get 4 to the 8th. Well, 4 to the 8th actually is a number, so if you use your calculator, I'll show you what button you'll push. You would take 4, and then there's I call it a caret key. I guess I'm not certain if that's the technical name for it, but this upwards arrow means it's going to use an exponent. Now I'm going to put my 8 there because I simplified 5 plus 3, and that's a huge number. It's 65,536. So 65,536. Now if they're just wanting you to simplify your exponent, then you just put 8 and you'd be done. Now for this one, I notice I have some fractions, but I'm not scared of fractions because I can add them pretty well. A half plus 3 plus a half. Well, this half and this half make one whole, and 1 plus 3 is a total of 4 for my power on my x. Now here I see negative 3, that's raised to the first power, I have one of those, and then I have negative 3 to the second power, so total I want negative 3 multiplied 1 plus 2 or 3 times, meaning negative 3 times negative 3 times negative 3. So 2 negatives make a positive, and one more negative makes negative. 3 times 3 is 9. 9 times 3 is 27. Now negative x. Negative x is my base, and I'm going to take my 3 plus 5 plus 2, and I will get negative x to the 8, 9, 10. Now, I want to show you this. It's very important that you note that both of these have parentheses, and I kind of showed a little bit of that here. When I take my base that's negative and I multiply it an odd number of times, meaning the power number is an odd number, 1, 3, 5, 7, 9, odd numbers, your answer is going to end up being negative, because an even amount, if you have a negative times a negative, make a positive, but that one extra because you have odd will mean your answer will be negative. Here, if I have 10 negative signs multiplied together, there will be 5 pairs of negative that cancel out and make positives, which means my final answer, a negative x times a negative x, a negative x times a negative x, negative x times negative x, negative x times negative x, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of these are going to end up being positive when I multiply two negatives. So when this is an even power, my answer will be a positive. So that's important to note here. Odd powers, you get a negative final answer. Even powers, you get a positive final answer. Now for the next one here, I have negative 3 times negative 5 times negative 5, or maybe I'll just put my numbers together. And I don't know why I wrote negative here. This 3 is positive. And I have 1, 2, 3 x's. If I multiply my bases together, or 3 times 25, because a negative times a negative makes positive, I get 75 x to the third. And that is my product of powers property.